So today we're going to be going over how to model with composite functions, and they've given us a word problem where we have to find an explicit expression that gives the average grade on an exam. So let's go and read through it. It says, Anais, a math teacher, noticed that the average grade on an exam, G, given that N students watch the related video, can be given by this function. So I'm going to go ahead and write that function down. All right, I'm going to write G of N, and G represents that's the grade, okay? That's the grade, the overall average of grades, and N represents the number of students that watched a video. Okay, kind of like you guys are watching a video, or you're not watching it. All right, plus 50 plus 1.5 N. So it looks like, for example, if let's say there were 10 students that watched a video, then the overall average would be 65. Like if you plug in a 10, 50 plus 15 gets you 65, like the overall average exam grade. All right. And then we also have another function. So I've highlighted this function right here. All right. And oh, this is a female teacher. Okay, so my apologies. All right. It says she also knows that the number of students S, so put S of M. So S represents the students in this function who watched an M-minute video can be modeled by S of M. So M now equals minutes. So M equals minutes. All right, by 30 minus M. It says find an explicit expression that gives the average grade on an exam if the related video is M minutes long. So ultimately our expression needs to be in terms of M. That's kind of what you're going to need to do. So I'm not going to simplify this, okay? I'm just going to go ahead. This is going to be the ultimate grade. So this says find an explicit expression that gives the average grade. So I know I'm going to be taking G of S of M. So I'm finding that the total number of minutes, that's my first input, is my minutes, which ultimately leads to my final grade. Now, if I wanted to stretch this out, here's what would happen here, okay? So here's ultimately what's happening. We got M, which leads to capital S, and then S becomes our new input, which is lowercase n, which leads to our ultimate output of G. So let's go ahead and label what these things are here. M is the number of minutes. S equals the number of students. N also equals, lowercase n also equals the number of students. And G represents what's called the final grade. All right, so this is our original input, which leads to an output, and then we take that output, make it the new input, which leads to a final output. So how am I going to write that? Right here. All right, I'm going to put 50 plus 1.5. I'm going to open up a big old fat parentheses, and now I'm going to take our function 30 minus M, and I'm just going to plug it in. 30 minus M. All right? So if we wanted to simplify that, all we would do, I'll go and kind of box in what we're doing here, right here. If you're getting a little too confused what we're doing. All I'm going to do right now is I'm going to go ahead and distribute, okay? So I have 50 plus 1.5 times 30, which is 45, all right, minus 1.5 M. Add these together, I get a total of 95 minus 1.5 M. All right, so this is what's called the simplified expression. We are trying to find G, excuse me, I'll go and do it in red here. g of s of m. And our final simplified expression is 95 minus 1.5 times m, or you could put negative 1.5 m plus 95. Now this is the simplified, but right now what I'm going to do is I'm going to show you that in the Khan Academy, as long as you type things in correctly, you don't have to simplify unless it says simplify. So I'm going to type in 50 plus 1.5 open parentheses that. So here we go. So right here, see where it says m minutes? That means I'm taking this guy right here and I'm plugging him in right there. So I'm going to type in a 50. Oh, not 5. There you go. 50. I'm going to put plus. Type in 1.5. I'm going to open up a parentheses. And for n, all right, which represents the number of students, I'm going to write s of m, which also represents the number of students, if m minutes of videos are watched. So this represents m minute of videos. So after I have that, this is the expression. Remember, the simplified expression was 95 minus 1.5 m, but I'm not simplifying it, and it'll still count it correct. If that doesn't make sense, go to see where it says see step-by-step solution, and you see right here, 95 minus 1.5 m, that was the simplified expression. All right, but you could type in g of s of m, which is this right here. Okay, so hopefully that was useful or important. Now this one's going to be a little bit easier, I believe. We're going to look. It says Carter has noticed a few quantitative relationships related to the success of his football team and has modeled them with the following functions. Well, good job there, Carter. Going above and beyond the call of duty. All right, so it says function n. I'm going to highlight different things here. So we have function n is dealing with winning percentage. Winning percentage has to deal with the average of number of I guess the more fans. If you have the winning percentage, the output is average number of fans. So if you have a good winning percentage, there's more people in the stands. Okay, I see it. I see it. All right, W is the average daily practice time. Gives us a better winning percentage. So the more they practice, the better they get. And then here, the number of rainy days impacts the average practice time. So here we go. So right now, we have 3 different input-output combinations. We have the winning percentage gives us an output of the number of fans that come to the game. The average practice time gives us a certain winning percentage, and then the number of rainy days impacts the average daily practice time. All right, so what we're trying to do now is we're trying to interpret this phrase right here, n of w of x. All right, so what does w of x mean? W of x means that the average daily practice time gives us a certain winning percentage. So this is our ultimate input, is what? The average practice time. So put average practice time. That's our average practice time. All right? Now, let's think about this. Our average practice time goes with the winning percentage. And then we got to find the winning percentage. The final winning percentage leads to the average number of fans per game. So what does n of w represent? N of w represents the average number of fans per game. So what was our original input? The average practice time ultimately leads to the number of fans that show up in the game. All right, so the average number of fans that show up is a function of the team's average daily practice, because this is our input that leads to an output, and then the winning percentage leads to the final output. So we're saying the final output, which is the average number of fans per game, ultimately depends on the team's average daily practice time. So I'm going to choose answer choice C, if it'll let me. There we go. All right. So we'll do one more here. All right, since it's basically the same concept. It says, which of the following represents the winning percentage as a function of the number of rainy days? Okay. all right, the winning percentage as a function of the number of rainy days. All right, so we got to find winning percentage. So I'm going to go ahead and, what were my colors last time? Blue. All right, we got blue. All right, I did red. And I did green. Blue, red, and green. And it says, which of the following represents the winning percentage? All right, so our winning percentage is our final output. So that's our winning percentage. That's our final output as a function of the number of rainy days. A function of the number of rainy days. So here's where I know my final output is W of X, which is the winning percentage. What did I have to plug in? I'm going to have to plug in P of R. And the reason why I'm plugging in P of R is R represents the number of rainy days. So this was our first input. That's the rainy days. And our final output was the winning percentage. So I'm going to find W of P of R. There you go. Okay. So like I said, if you want to see a step-by-step solution, you can kind of read through it. I tried to do my best job explaining how I go from the original input to the final output. Here, this was the output, this was the original input. So the last thing I'm going to do is I'm going to write this was our final output, which was right here, and our original input was right here. This was our original input. And that's all I have to say about that.